Okay, in this video, we're going to talk about chain and sprockets. So, chain and sprockets are very similar to timing belts and pulleys, where the chain is acting like the belt and the sprocket is like the pulley. So, we could also have a different gear ratio to get a mechanical advantage. So, the same concept applies. So, they're also very similar to gears since we said that timing belts are similar to gears. So they're all pretty much in the same family where they all act as some transmission mechanism where there's teeth involved, and based on the spacing, you have a certain pitch you have to align to. And like the gears and timing belts, there's also idler sprockets. That's some you could place them somewhere in between, either for tensioning or it could just be for redirecting. And the chains typically come in you could have little segments that you can adjust as needed or for replacement. There's like super flexible ones. Some of them have double rows. Just depends on what type of assembly that you have. Okay, so we could open up a tab for the sprocket and another one for the link. So you can see here that for For this one here, we have a specific number of teeth, and this is for a fourth inch pitch, all of these. So we could go ahead and choose one of these. Okay, so let's go ahead and download this, and we'll put it in our chains and sprockets. So we see that this one has 9 teeth, a shaft diameter of a fourth inch. It uses a set screw to hold on to the shaft. It has basic hub diameters. And then for the chain, we see that this one's for a pitch of a fourth inch. And this one is, you have a roller diameter, roller width. The length is in these different increments. So we could choose a length that we want in feet. So let's say if we go with a 2 feet one, could download this. Okay, so I don't think that it's gonna show you the right length when you download, but when you order it, it should be in the right one. So yeah, you can see I chose a 2 feet one, but it'll just download a small segment. So in practice, if you want to put it in your assembly, you might need to draw your own loop to show it in action. Okay, so see that this has a spec of a working load of 140 pounds. So this gives you an idea of how to size your assembly. Okay, so let's just put it in assembly so you can see how all the parts look. Even though it doesn't loop around, we could at least see what it looks like. So this is our chain, and then this is our sprocket. So you can have a bunch of these stacked up like so. And we could go ahead and insert our sprocket here. Okay, so it'll look something like this. Right now, these are just floating, but you can imagine that this one would link in here like so, and then this face could be coincident to that face. So if I were to just drag this, and I'm gonna just let it float for now, but you could see that the chains will engage like this, probably go down a little bit more. And then the chain will be rolling. Maybe usually there's going to be two because you have one that's driving and then the other one that's driven. So you'll have, typically, you'll have two chains like so. And then the shaft will usually be in some fixed location. And then as this is rotating, the other gear will rotate with it. Okay, so like I said in practice, because these chains are not in a circle, you may need to draw your own loop to show the circle, and then you can see how the mechanism works. So when you mount these sprockets, you're gonna treat them the same way as we did with the gear. So you're gonna have a shaft that goes through, and then some mounting plates perhaps with a bearing, so that this can spin on the shaft, and the shaft will be rotating relative to the bearing. And then you could do some methods to contain the shaft using the shaft coupling or the shaft collars or retaining rings or things like that. But pretty much all the concepts that we talked about that we talked about previously applies. Right here we have two sprockets that's the same size, but you could go ahead and choose a sprocket of a different size for, let's say, the output, and then you will also get a mechanical advantage. And then for tensioning too, you need some way to tension this, just as we talked about for timing belts. So um, some ways of doing that is, let's say your belt were longer, you could have, for example, a third idler, and this third idler could be shifting downwards so that it's creating tension on the chain. And another way is you could have one of the chains to be moving. So you can imagine this the sprocket here could be on a block, and maybe the block is sliding, and the block could be adjustable either by a screw, or maybe it just slides freely on a slot. Then when you pull it, it can tension accordingly. So let me actually do a sample block of what that may look like. So if we click here, I'm gonna make a block. Let's make this 0.25 inches, and I'll call this mounting block, and I'll put it in my sprocket folder. Okay, so I'm gonna mate it to this face for now. Let's just make it parallel. So if I'm normal to this, just imagine there's a block like that. And I'm gonna slide it over. But right now, these things are just floating. So um, let's imagine that we have a full set of chains. So there's maybe one right here, and then one right here. Let me retract this actually. Okay, so just imagine there's like a full loop of chains that wraps around. Let me just free drag it so it looks closer to what we would expect. So, okay, so just imagine there's a full loop that goes around, and then you have one sprocket that's free to move to adjust. So, one way of doing this is, let's say we have a block here, and this one is about zero point 0.5 in diameter. So, we can make a small block that's not too big. Maybe this is 1 inch, and then this is 0.5. And we can make this a 0.25-inch block. And the diameter of this was 0.25. So we could sketch a circle here that's 0.25. And you could use hole wizard to be more proper, but I'm just gonna make a quick hole here. So I'm gonna extrude cut this, sure, through all. And then the key part is maybe you have slot here. So I'm gonna do a straight slot. And maybe this is 0.125, which is too big. And I will just extrude cut it here. And then why don't we mirror this? Okay, so just imagine there's a block like this with slots, and we'll just call it block with slots. And we could mate this to here, and then maybe this face to, let's see, I'll click this edge because it's kind of hard to click. Okay, so it'll look something like this. And let's make this parallel. Or let's fix this plate and then make this to be parallel. Then if we go normal to this, okay, so now you can see that if I view the top, I just have these floating, but can match. Let me float this now, and then we'll move it somewhere like this. Okay, so now what you can imagine is if there's a screw that goes through these slots, you could have one of the chains on this block that slides, and then when this block, let me fix this. If this block slides back and forth, it could create tension, which will allow our assembly to, okay, this is going to allow our assembly to create tension in the chains. Okay, so you could pull this back and forth now, and then you could have, in this case, actually it might be better to have the slots on the other side, or you could have like two slots. You could have both plates slotted, and then maybe a nut on the back, and then you could tighten the nut once this is in place. Or another way is to just have actually this block with the threaded holes and this main plate with the slots, and then you could slide this block relative to this plate. So that actually might be a better approach. But the main idea is that the sprocket will be on a sliding block, and then you adjust the block until you get the right tension. And then once you get the right tension, you could have everything in place. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one.